The process begins when a motor neuron sends an action potential to a muscle cell. This action potential travels down the T-tubules, which are extensions of the muscle cell membrane that penetrate deep into the cell. The action potential triggers the opening of voltage-gated calcium channels in the sarcoplasmic reticulum, or SR, a special organelle that stores calcium ions. The sarcomere is separated into Z lines, which anchor thin actin filaments. The distance between two Z lines defines one sarcomere. The I band contains only thin filaments, or actin. This band shortens during contraction as actin slides inwards. The A band is the length of the thick or myosin filament. This length stays constant during contraction. The H zone is the central region of the A band with only thick filaments. This zone disappears during contraction as actin filaments move inwards. In a fully contracted sarcomere, the I band and H zone narrow or disappear where an actin fully overlaps myosin. The Z lines move closer together when the sarcomere shortens. This is called the sliding filament theory, which explains that contraction occurs because myosin pulls actin inwards without filaments themselves shortening. Calcium floods into the sarcoplasm, the cytoplasm of the muscle cell. Calcium binds to troponin, a regulatory protein on the actin filament. This causes tropomyosin, another protein, to shift its position, exposing the myosin binding sites on actin. The myosin heads, which are part of the thick filaments, bind to the exposed sites on actin, forming cross bridges. This binding requires ATP, which is hydrolyzed into ADP and inorganic phosphate, providing energy for the process. The myosin heads undergo a conformational change, pulling the actin filaments towards the center of the sarcomere. This is called the power stroke. As a result, the sarcomere shortens and the muscle contracts. When the action potential stops, calcium is actively pumped back into the SR by calcium ATPase pumps. Tropomyosin recovers the myosin binding sites on actin, and the muscle relaxes.